Hi, Andrew here, and today I would like to teach you how to find the x-intercepts of a particular function. And the function we're given is f of x will equal x cubed plus x squared minus 20x. I'm going to try to teach you how to do this algebraically, but I'm not only going to be exclusive to that particular mode. All right, but let's just keep in mind what we have to do. Pretend you have a function, something that looks like this, and I don't pretend that this function up here is going to be a linear line. But what I'm trying to illustrate here with the graph is what do we mean by x-intercept? Okay, well, we know our x-axis is generally the horizontal axis, and our vertical axis is the y value or the f of x value, right? The function's value. To be an x-intercept, what that means is that you want to find the location at which the function crosses the x-axis, okay? And there's always one unique property about every single x-intercept, every one of them. The unique property is that the x-coordinate will be some value, and the y-coordinate will always be 0. Y will always equal 0. So in other words, whenever you get a question of saying find the x-intercepts, or what is the x-intercept, or whatever the case is, really you want to ask yourself, what are the values of x that make this function's value become 0? Okay, what are these x values so that when you do the math on the right-hand side, it equals 0 on the left-hand side? Well, it would also equal 0 on the right-hand side too, right? But that's the thought process, okay? Now, just do a little thinking first, okay? If you had this function, I'm going to change my f of x value to y. It really doesn't matter, they're tomato, tomato, okay? So x cubed plus x squared minus 20x. Now, if this side has to equal 0 somehow, what do you think could be a value for x? What do you think? Well, I mean, looks to me like if it's 0, right? That might work. If this is 0 and this is 0 and that term is 0, well, 0 plus 0 minus 0 is, I don't know, 0, right? So what that means is that if x could equal 0, if x can equal 0, I know my y value will also equal 0, so that's going to be one of the x-intercepts. Okay? Now you can do a little more thinking, but I think this gets a little harder, right? I mean, I think this gets a little harder. You can kind of imagine if I slowly increment now x in the positive direction, right? This term is going to become really small, and these are really still very small. I think there's going to be some value there in the positive direction that might have this thing come out to be 0, but it's a lot harder now, okay, to kind of estimate what that number is just by looking at it. Now that's the benefit now of some of the mathematics, okay, some of the techniques, because we have a rule, we have some rules that we can follow. So the idea here is the first step whenever you're trying to find the x-intercepts and you're given a complicated function is you want to try to begin to factor stuff. In other words, you want to try to find you either want to group these terms somehow to pull out common factors, or just look at the overall function and start pulling out some common factors. So the first thing I noticed that's in common amongst all three of those things is going to be the x term, right? This has an x, that has an x, and that has an x. So what I'm going to do is pull out a common x, and every now term I have to reduce by an x value. So the first term becomes x squared. The second term there becomes x to the first. I'll just leave that out. And then the third term becomes just 20, right? We drop the x. Now, consider why we're going to factor. Why we factor is because now we have something set up like this, where, consider now the logic, that if this term outside of the parenthesis could be equal to 0, right? If this thing is 0, this whole side goes to what? It's 0, right? 0 times anything, I could care less what's in that parenthesis, is 0. I don't care if it's negative, positive, whatever. Okay? It's 0. Also consider that if the value inside of this parenthesis is 0, then I could care less what this value is outside of the parenthesis, because remember, 0 times anything, right? If this whole thing is 0, that 0 times anything is going to be 0. Right? So the reason why we're factoring is because we're actually breaking this function up into two now unique pieces. And we're trying to say, hey, if only that term equaled 0, how do we write that mathematically? Well, we write x equals 0, right? Because that's the only thing that's outside of those parentheses. And then I'm going to write this inside, x squared plus x minus 20. If only that whole thing were equal to 0, right? Then I know this whole function's value would be equal to 0. Okay? So, I already have one of the answers. Look, that's what we said it should be by just thinking about it, right? So there's one of the values, okay? But now we're on this particular side and we got some complexity there, right? Now what you can do is you can program the quadratic function in your calculator. By the way, check the link below. I'm going to leave you a description. Not a description. Check the description below. I'm going to leave you a link down there to program your TI calculator to put in this quadratic function. So watch. I'm going to go to program on my calculator just real quick. I'm going to go to my quad program right there, hit enter. I'm going to hit enter again to run the program. So my a value here, remember, when you look back to here, your a value is in front of the x squared, right? That's your a. Your b value is in front of the x term. That's also a 1. And then your c value here is going to be the negative 20. Okay, so watch. If I go a is 1, hit enter. B is 1, hit enter. And then c is going to be negative 20. Watch. Look at that. It gave me the values of x, right? X is going to be, it tells me right here now. It tells me right here that x is going to be equal to 4 and x is going to be equal to negative 5. Okay? Now, let's say you're like, well, that's great, man, but I don't have that in my calculator. So what am I going to do? Don't fear. Andrew is here. So what are we going to do? Okay? So you now have to recognize this pattern, right? I mean, a lot of mathematics is pattern recognition. And you're only going to become good at the patterns, by the way, by doing a lot of practice. I mean, this is not something you're going to sit there, and just watch and then just all of a sudden magically be like, oh, this is easy, and then you get to the test and you're like, oh man, it was so easy when I was watching that video. What happened? Well, you didn't practice, right? It's just like if Beethoven were to rise from the dead, right, and start playing the piano and I watch him, I can watch him all day long for years. I'm never going to play like him, okay? But if I watch him, learn from him, and try to practice, right, what he's doing, what he's teaching, then maybe one day I can play like him. Right? So practice is really, really important. Now, pattern recognition, you're going to recognize this by doing a ton of practice. This is a quadratic function. How do we find or how do we solve quadratic functions? Remember, the goal here is to select two numbers that multiply to negative 20. Okay? So a times, well, I don't want to use ab, that might confuse you, but x and y will confuse you too. So maybe k, now, two numbers that are going to multiply to negative 20, but that yet are going to add up to a 1. That's what has to run through your mind. Okay, so you're like, two numbers, okay, they multiply to negative 20, but add to positive 1. Oh, I got it. What about a positive 5 and a negative 4? These would multiply to negative 20, but yet add up to a positive 1. And I say to you, yes, you got them. Now, ready? What we do now is we do this. Let me change the color. What we do is we do this now. We do x. We said plus 5, right? Because we said a positive 5. And then we have now x minus 4. And that should equal 0. Right? Now, we now factored this. We broke it down into two binomials. And what I realize now is I have the same setup as I did here, where I had one factor here and one factor here. And I realized if this was 0, the whole thing would go to 0. And if this thing inside the parenthesis was 0, it would go to 0. I got the same setup now. Look, if this thing inside of the parenthesis here is 0, then this whole side goes to 0 because they're multiplied, right? Or if this thing goes to 0, then this whole term goes to 0 because they're multiplied again, right? So how do we say that mathematically? Well, we say x plus 5 should equal, that term inside the parentheses should equal 0, or my x minus 4 should equal 0, right? Now solve this for x, because that's really what you want to find, right? You want to find that x value when this whole term is equal to 0, so just subtract the 5 from both sides. So x is going to be minus 5. There you go. And then add the 4 on both sides. And look, x is going to be positive 4. And OMG-ness, isn't that what the calculator told us? Right, it is. You don't want to rely on it, but there, we checked ourselves. Okay? So you really have three values. X should be equal to negative 5. X should be equal to positive 4. Right? And if you want to see it visually, now go to your graph. All right? Graph the function. So x cubed plus then, no, careful, you got to hit over. Well, what the heck did I press now? Okay, hit over. There you go. Plus x squared minus 20x. Graph it. I'm going to zoom out for a minute. I'm going to go to zoom standard. Okay, good. So this will be good enough. If you notice here on the graph now, I'll blow this up a little bit. Okay, but if you notice, this thing is going to cross the x-axis 3 places. 1, 2, 3. What's the x value over here? Negative 1, negative 2, negative 3, negative 4, negative 5. Check. Okay, what's the x value over here? 0. Check. What's the last one? Positive 1, positive 2, positive 3, positive 4. Check. Right? Good. That takes care of that. And then you can also even use your table if you want. I got to set my table. I'm going to increment it by 1. So go to second graph. And now, look. Here's everything on the screen. When y is equal to 0, that's what we defined the x-intercept to be. X would be negative 5. When y is equal to 0, look, x is equal to 0. And when y is equal to 0 here, x is equal to 4. So what we said, look at how many different ways there are, okay? But that's all it is. It's not bad, right? It's very simple. But this is how you approach it. And this is how you, more importantly, think about it. Guys, thanks very much for tuning in. I really do appreciate it. I do hope this video helped you out. If it did, if you don't mind giving us a hand, like, subscribe. And the best way would be to actually also to tell your classmates or tell your friends. All right, if we're able to help you out, we'd love to help more people. And maybe we'll be able to help them too. All right. Yeah, it would mean the world to us. We're so thankful for everyone's support. And that's honestly what keeps us going. So with more support, you actually motivate us to do more. By motivating us to do more, we produce more, we help more people. It's a very nice, virtuous kind of thing. All right. We really appreciate everything. Take care.